Hi, my name is Ann Isaacs. I am a second-year graduate student in astrophysics at the University of Minnesota, and today I will be presenting to you my research on the expansion of the universe and supernovae. So let me first share my screen with y'all. Right. So the universe is expanding. When we're sitting in one place here on Earth, we see every galaxy moving away from us. And in fact, if we were in another galaxy, we would also see every other galaxy moving away from us. This is the raisin bread expansion of the universe model, where every galaxy is like a raisin in raisin bread. And when the dough rises, every raisin moves away from every other raisin. The universe is expanding. So the first thing we wanted to do when we figured this out was figure out how fast is it expanding? And there's a lot of ways of doing this. The one I use is called the standard candle method. So this is like this lovely picture here with all of these birthday candles. We know how bright the candle is. So the ones really close to us will seem really bright and the ones really far away will seem very dim. And by doing some mathematics, we can figure out, knowing, the underlying brightness, how far away the dim ones are, which is pretty cool. So the method I use for this are type 1a supernovae, which we used to think were all exactly the same. It turns out that they are not all exactly the same. We thought they were, they're not. The first thing we figured out is that bright ones fade a lot more slowly than dim ones. And turns out that, there are some that are bright and some that are dim, which is a problem. But we were able to sort of figure that one out and correct for it. So you can see over here on this plot on the left, we've got our different brightnesses of supernovae, and over on the right, we've corrected them, and they're almost all the same, but there's still a lot of scatter. You can see that these dots aren't exactly following this black line, which we'd really like them to, because then they would all be exactly the same. Instead, they're, some of them are a little high, some of them are a little low, and we don't know what causes that. And maybe it's important. So what makes them different? And that's what I'm studying. I'm studying whether or not the environment a supernova happens in matters. So this is like saying that birthday candle, maybe when one of those candles was made, the factory made a mistake and the wax is very different, or the wick is very different, or maybe somebody put a lampshade in front of one of them. Who knows? So what I need to do is figure out if there are different environmental factors that are affecting the supernova. The first problem with this is, as you can see from this photo on the right, supernovae are very, very, very bright. This bright dot in the bottom left, that's a supernova. It's nearly as bright as the whole galaxy. So what I have to do is wait up to 10 years for them to fade away and be done. And then I look at the galaxy and I take something called a spectrum, which is basically where I pass the light through a prism and make a rainbow. And then I can study the different colors in that rainbow and see things like star formation rate, or how many heavy elements there are, like how much carbon is there floating around. Does that matter? And by studying these different factors, I can understand how different, I can hopefully understand how different environmental factors like heavy metals or star formation affect the supernova itself. And hopefully I can figure out some of why they're not all exactly the same. And if we can figure out why they're not all exactly the same, we can figure out how to use them to really understand the expansion of the universe and, with any luck, pin down that measurement for good. Yeah, results are on their way. I don't have any for you right now, unfortunately. Thanks very much for listening. Yeah, enjoy the rest of SciPride at the Bell Museum and have a great day.